what the x is committed.
Mm-hmm. Okay, and we put our 5. What do we do with that 5? And then what did we do? Mm-hmm. And complete our square. So middle term divided by 2 squared. So -6 divided by 2 is -3, squared is 9. If you add 9 to one side, you add it to the other. Right, same thing with this. 8 divided by 2 squared. 8 divided by 2 is 4, squared is 16. So we add 16 to both sides. So what multiplies to 9 and adds to -6? Mm-hmm. So it's x minus 3 squared. Multiply 16 and add to 8. So 5 plus 4 squared. And if I add those, we get 20. So our center, I told you, it's just like setting each of these equal to 0. If you set x minus 3 equal to 0, you get 3. If you set y plus 4 equal to 0, you get -4. Remember, 20 is r squared. So to get the radius, you have to square root 20. You can break that into 4 and 5, so you get 2 radical 5. Any questions there? Second one, solving quadratic equations. I didn't tell you how to solve them, just to get the solution. What would you have to do first on A? Distribute. I can't just say set each of those things equal to 16. That only works if it's equal to 0. So we have to multiply it out first. And let's subtract over that 16. Now what would you do? Mm-hmm. Okay, what multiplies to 48 and to -48 and adds to +22?
-2 and +24.
Have to divide our 3 back. So we get 3x minus 2, x plus 8 equals 0. So to finish it, we just set each of those equal to 0. That gives me 2/3 and -8. Did you guys get that one? And the last one. What could I do to solve this? There are different options, but maybe the easiest one, we only have x in one spot. We could get it by itself. If I bring over the 81, square root, if you add a square root, you have plus and minus. What's the square root of -81? It'd be a positive and -9 on that one. So you could have tried like completing the square or something there. It just wasn't necessary because we only had the x in one spot. We were able to just isolate it. Any questions there? So we are going to finish this section today. Let's get out the notes that we've been working on. We've talked about solving quadratics by factoring, by square root method. We did completing the square Friday. And our problems to review that, practice all those techniques. We did the completing the square within our circles. So the last thing we have for solving our quadratic equations is the quadratic formula. This works on every single quadratic as long as it's written in the form ax squared plus bx plus c equals 0. So x is the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. I am not giving you this formula this year. So you've used it in Algebra 1, used it a lot in Algebra 2. It's something that comes up a lot. You really need to know it. On the ACT, you'll use it to solve problems. It's not given to you there. Okay, so I want you to know this formula. So let's practice a couple. So if I asked you to solve this quadratic equation, what should we do first? It has to be equal to 0 to start with. So now my A value is what? 1. B is, and C is 2. Would this one factor nicely if we tried? Does anything multiply 2 and add to -4? No. Okay, so X equals the opposite of B. The opposite of -4 is 4. Plus and minus the square root of B, so -4 squared, minus 4 times A times C, all over 2A. So -4 squared is 16. 4 times 1 times 2 is 8. So I get 4 plus and minus the square root of 8 over 2. What do we need to do now? Before we do that, let's talk about that square root of 8. We can break that down into 4 and 2. So we get 4 plus and minus the square root of 4 is 2, radical 2 over 2. And then we can divide everything by 2. So 2 plus and minus the square root of 2. Now, if you really like completing the square, could you solve this one by completing the square? Absolutely. Both completing the square and quadratic formula work on any problem. Let's do another one together. So does it matter if I move over my 2x squared or my x and, no. In quadratic formula, unlike when we do slip and slide or complete the square, A can be negative, so it doesn't matter. It's just whatever you're most comfortable with. So which side do you want to move everything to? Okay, so it would be 2x squared, subtract the x and add the 4. Alright, then from here, my A is 2, my B is -1, my C is 4. So x equals the opposite of B would be 1, plus and minus the square root of B squared minus 4 times A times C, all over 2A. So under my square root, I have 1 minus 32. That's the square root of -31. What do I need to do there? And so then to finish it, since it is an I, we do have to separate it. So just 1/4 plus and minus I radical 31 over 4. want you guys to try one. I think most of you just added over the 5. We have made 3x squared minus 2x plus 5 equals 0. So a is -3, b is -2, c is 5. So the opposite of b would be +2, plus and minus the square root of b squared. Notice I put that -2 in parentheses because when you square a negative it becomes positive. Minus 4 times a times c all over 2a. So that gives me 4. -4 times -3 times 5 is +60 over -6. So you get 2 plus and minus the square root of 64 over -6. What is the square root of 64?
8.
All right, a lot of you reduced it right here, which is fine, but we can finish this. You can do 2 plus 8 divided by -6 and 2 minus 8 divided by -6. 2 plus 8 is 10 over -6 reduces to -5/3. 2 minus 8 is -6 divided by -6 is 1. So you should get -5/3 and +1. If you get a nice answer like this, that means slip and slide would have worked on the original problem, but it doesn't matter, this way gets us there too. Do we need to do another one? Sometimes we aren't asked what the answer is, we're just asked what kind of number we might get. Like, why did I get an I on problem B, but not problem C?
This is the square root.
Right, the thing under my square root was negative. Okay, how come answer A still had a radical in the final answer, but B didn't, C didn't? Right, it's all based off what's underneath that radical, right? So if you have a positive number under that radical, we get real answers. We don't have i's in them. And if it's a perfect square, we'll get a nice rational number at the end. No radicals involved. If it's a negative under that radical, then we get i's in our problem. What would happen if it was 0 under that radical? Yeah, the square root of 0 is 0. So you would have like something like 2 plus or minus the square root of 0 over whatever, maybe 4. Well, square root of 0 is 0. 2 plus 0 and 2 minus 0 are giving us the same thing, right? We're just getting out one answer. So that's what's called the discriminant. It's just the thing under the square root, b squared minus 4ac. It doesn't even include the radical. If it's positive, you get 2 real solutions. If it's 0, you just get 1 repeated solution. I get the same thing twice. If it's negative, you get imaginaries. And we should clarify here, if it's a perfect square, that answer will be rational. It'll just give us a nice fraction at the end. If it's not a perfect square, we will still have a radical in our problem that's called irrational. All I want is the number and type of solutions. So I'm not asking you to solve it. That means I don't have to do the whole quadratic formula. You certainly could, but all I really need to know is what's going to happen under that square root. So all we need is that b squared minus 4ac. What's my b value on this one? -5 squared minus 4 times, what's a and c? So I get 25 minus 12, which is 13. Okay, so think about it. If you do the square root of 13, will that be real or imaginary? It'd be 2 real. Will it be rational or irrational? Irrational. Rational means no more radical. This is a positive number, so it'll give me real answers, but it's still going to have a radical in it. So they would be irrational numbers. On B, what would I have to do? Mhm. So my B is negative 1/4 squared minus 4A is 3/4, C is negative 1/2. So negative 1/4 squared is 1/16. This would give me plus 3/2. Which is 25/16. So that's positive, so that means they would be real. Can you do the square root of 25/16? Yes, so that means it will be rational. The radical will go away altogether. I want you guys to do C. Please subtract over 4x. B squared minus 4AC is a 16 minus 24 or negative 8. That's our discriminant. That's negative, so that means we get good. All right. Any questions about those? Okay. Then the last thing I want to do. If I asked you to take an equation and solve for a variable, could you do it? So if I said solve A equals pi d squared over 4 for d. Am I going to get a number answer here? No. But could you get the d by itself? Yeah, what would you do?
Divide, or multiply by 4.
4a equals pi times d squared. Then what would you need to do?
Divide by 5.
We get 4a over pi is equal to d squared.
And then, square root.
We don't know, I didn't tell you what these variables stood for. If you don't know what they are, then when we add a square root, we have to do plus and minus, right? But if I gave you some context and said, you know, d was the diameter of a circle, could that be a negative number? Well, diameter is just the length across the circle. So the distance across couldn't be negative. So if I don't tell you what the formula is for, go ahead and do the plus and minus. If I tell you what the formula is, think about it and make sure that both positive and negative make sense. All right, I want you guys to try one of those. Then what would we do to get r by itself? Divide by pi. Could I divide by my h at the same time?
Yes.
Yeah. You could do it in 2 separate steps or all at once. So 3b over pi h is equal to r squared. And then what would we do?
Square root.
Square root. Since I didn't tell you what the variable stood for, we would need plus and minus. If I told you r was a radius, would you need the plus and minus?
No.
No, a radius is a distance, it couldn't be negative. So depending on the context, you may not need a plus and minus, but if I don't tell you, you have to. Go ahead and put it there. All right, any questions for me? So, Math Excel assignment for today, and there is a quiz tomorrow.